So as you know, this event is part of the 2Rivers Festival, where we're going to celebrate and appreciate the Speed and Eramosa Rivers. And we want to thank Nature Guelph for their second event in the festival and for sharing their love for our rivers. And thanks to all of you for attending. This event is organized and run by volunteers and involves many community organizations, 40 altogether. So we'd ask you to support them in their push for memberships and in their activities. And also to support our advertisers whose logos you're seeing now. And they're in our festival book and on our website. And especially to our event sponsor, the Guelph Outdoor School. Their generosity makes this event possible. So we have 40 events through May and June. And within 2 months, they've all virtualized themselves. It's amazing what they've done. So we'd like to thank them and encourage you to sign up RSVP to any others you're interested in. And this festival is a project of the Wellington Water Watchers. And their motto is, if we fall in love with our rivers, we'll want to protect them. So just some reminders to keep your mics muted during the presentation because we get the background sound. And Abbie would like you to either put your questions in the chat room, or at the end when she's finished, you can unmute yourself to ask questions orally if you'd rather not use the chat room. And note that the session is being recorded. That's for people who've signed up and want to watch it later. So if you don't want your image on the recording, then just blank out the video. And the sessions will be available for viewing in a few days, and eventually they will be on YouTube. So that's all of our housekeeping. And now it's up to me to introduce Abbie. How are you doing now, Abbie? Okay?
Hi, everyone. Nice to meet you.
So I'm going to introduce Abbie, and I want to thank her very much for doing this for us. Ironically, it's a lovely day and we could have been out walking around in the river, right, Abbie? Instead of on the screen. But anyway, here we are. So Abbie is completing her undergrad degree at the University of Guelph in environmental science with a focus on entomology. She's volunteered as Nature Guelph's University Community Liaison from 2016 to 2019. And she's now registered as a grad student working towards completing a master's thesis at the University of Guelph. And she's studying the newly invasive box tree moth. So we have another one to worry about, do we? Have another invasive?
Unfortunately.
And she's very excited to talk about all the incredible creatures that are found in Guelph's rivers. So I'm going to turn it over to Abbie, and she's going to tell you what she wants to tell you. Abbie?
Thank you so much, Susan. We really appreciate you hosting, and please, everyone, bear with me. I have used presenter mode before, but just getting this started. We'll see how this goes. Thank you, everyone, for attending. That you don't mind being inside when it's sunny. I'd like to say that I'm here today with Nature Guelph. I've volunteered with them in the past and continue to be involved and active with the community. Nature Guelph strives to connect people with nature and inspire them to celebrate and protect it. Now, today, as you're aware, we're going to be talking about fins and shells within Guelph. Just an overview of what I'll be talking about today. A lot of times we don't know when we see bugs, we don't know if they're insects. Going over that, we'll be talking about the characteristics that an insect. Of course, we'll be talking about the creatures found in the deep blue rivers of Guelph. And then lastly, as Susan said, we'll have a question period. Now, Guelph is actually very rich in waterways and locations. I actually took this image off of a City of Guelph webpage where you can go and view all of the different watercourse locations within the city. A lot of the times when we're out and about in a city setting, we might think of wildlife such as ducks, maybe if you see a fish or two, especially turtles, and other events have talked about these, but what I'm going to be talking about and focusing on are the aquatic insects that exist in our rivers. They're maybe a little lesser known and a little harder to find sometimes. In order to talk about how to identify insects, I wanted to go over just a basic overview of how we classify things. Now, all creatures are classified based on shared characteristics. This is called the classification of living things. At the top, we have domain, then kingdom, phylum, class, order, family, genus, and species. Now, today we will be focusing on the phylum Arthropoda, which contains Insectica. As I said, Arthropoda contains the class of insects, but a lot of times when we're out about in nature, we might see a manner of creepy crawly things and we might say, oh, look at that bug. But do we actually know if it's an insect or not? So within Arthropoda, it also contains the classes crustaceans, arachnids, and myriapoda. Crustaceans include things like crabs, lobsters, especially in southern Ontario, we'll see crayfish, and also we have one terrestrial crustacean, which are the pillbugs. A lot of gardeners will see these when they're clearing out leaves or working in the dirt. They're the ones that crawl up, and I've called them roly-poly bugs as a kid. These are actually terrestrial crustaceans, so I think it's really interesting. Now, moving on, we also have the arachnids, spiders, scorpions, mites, and of course, something that's on everyone's mind are ticks. So that's in that class. We have insects, beetles, flies, true bugs, and butterflies, and we'll be talking and focusing more on that coming up. Lastly, we have the myriapoda, which are centipedes and millipedes. Now, just a very quick overview. If you ever come across something and you want to identify it, spiders all have 8 legs, even ticks. All arachnids, they have 8 legs, so 4 pairs on either side. Crustaceans will have 7 or more legs, and of course, centipedes and millipedes have many, many, many legs. Oh, I think my computer might be frozen.
Oh, it changed.
Sorry. So now we will go on to what makes an insect an insect. These special characteristics, as I talked about with the other 3 classes, the characteristic of an insect is that it has 3 body segments, and this is separated into the head, thorax, and abdomen. Now, the head contains compound eyes. If you've ever stared at a fly, you can see that it looks like multiple panes of glass all clustered together. So these are the compound eyes. They have the mouth parts and the antenna. The thorax, which is the middle segment of the body, contains all of the legs, and there are 3 pairs on either side, or 6 in total, and they're also jointed. And the thorax is also where the wings attach. And all insects have 2 pairs of wings, sometimes as pictured here in our diagram. 1 pair of those wings are actually a hardened, adapted form called the elytra. And this is really common in beetles. Now, other characteristics of an insect include an open circulatory system, This is where oxygen exchange happens through spiracles, which are often whole along the side of the body, or other orifices. And this is where gas exchange happens directly with the blood system. As I said, antennas, compound eyes, and sucking, chewing mouth parts. Another important aspect that we need to think about for the rest of the presentation are about insect life cycles. There are two main categories for two main development stages that insects undergo. About 20% of all insect life will undergo what's called incomplete metamorphism. Now, this is where the immature stages are called nymphs. They often resemble the adults and inhabit the same spaces, habitat, and feeding patterns as the adults. Now, as the nymphs grow, they go through larval or nymphal instars. So that's what that diagram shows, and they do not have a pupal stage. Now, the other remaining 80% of insect life undergoes complete metamorphism. Now, this is where you have a complete separation between immature and mature life stages. They look completely different. A butterfly is a really great example of this. The larval stage, or what we call caterpillars, they inhabit and eat completely different materials than the adults. And this stage involves a pupation. So they move from larval to pupa to adult. The complete metamorphism is one that will become more apparent and important in later talks. So now I'd like to talk about all of those creatures that we may be finding in Guelph rivers. And I want to know after, maybe during question period, if you've ever come across these. Do you recognize these creatures? Something that's on everyone's mind right now, especially mid-May and amongst the hot weather, are black flies. Now, black flies are within the order Diptera, which are flies, and then the family Simulidae. The reason that these insects are especially ones that are first emerging in our springtime is that they actually overwinter as eggs or larvae in the substrate in the bottom of our rivers, and then can emerge as adults really quickly. Now, their body, and this is true of many insects, actually contain a sort of antifreeze that's made up of certain sugars. This antifreeze allows them to be freeze tolerant so that they can survive extremely cold temperatures and still live. Something that I think is really interesting is that the larvae actually have a silken pad on the underside of their body, which they will stick to the substrate. It can be seen here in the photo on the left, and then they kind of just float in the air, well, air, I should say water, and filter the water to gain their nutrients. As they move to their pupation stage, they actually do this underwater, which is different from a lot of the other species I'll be talking about today. This means that the adults, when they emerge from their pupal case, actually have to ride air bubbles to the surface and then break the surface tension of the water and fly away. As I'm sure you know, it's really annoying to be bit by a black fly, and you're probably wondering, how do they ever find me? I come outside and I don't see them. But they're actually attracted to the carbon dioxide and moisture that we exhale in addition to our scent. And this is the same kind of locating mechanism that they use for all mammals. The females are the only ones that will consume our blood. They use this energy to produce their eggs. Sorry, bear with me. It seems my computer is a little slow in changing slides. Now, another one that I always think of when I think of summertime and you're kind of enjoying patio life and you have your lights on are crane flies. A lot of people think of them as giant mosquitoes. And if you've noticed, they're kind of awkward flyers. They bump into things. They're not very graceful. But something that's really interesting is that a subset of species within Capulidae, which is the family name for crane flies, are actually a larval, or actually aquatic. Their larval stage is aquatic. And the photo on the left there is, it is a little bit bigger, but it really almost matches the exact size of the larva. I'd say that it's, I found ones that are almost the same size as my finger here. They can grow quite large, and they hang out in the substrate at the bottom of rivers and feed on the algae that exists there, the algae and bacteria. Now, unlike black flies, these guys actually have to crawl out of the water to pupate on land. Something that's important to note is that they do not bite. The larval stage, of course, does not bite, but the adults don't bite either. And in both of their life stages, they are important foods for fish and turtles, and then terrestrial for birds and bats. Now, something that this is a species that would be really easy to find if you have any sort of water source nearby. I was actually recently just at my cottage and just looked down in the water and saw about 20 of these crawling around. Caddisflies are a really attractive species to a lot of fishermen, if you have any in the audience today. Their adult stages are an important food source for trout, and fishermen actually take painstaking detail to mimic these to make lures. Now, something that's interesting about this larval stage is that they have their gills along their thorax, which is the middle of their body or along their abdomen. Their abdomen is extremely soft and vulnerable to predation. So a lot of species within this family actually build their own houses. And this is the photo that you can see to the right. They use a silk made by their salivary glands, which is water resistant. And I'll show you a video in a second that explains this in some amazing detail. Before we get into that, I wanted to talk about that there are 4 different types of feeder structures within that caddisflies usually fall into. These scrapers actually will crawl around the substrate and feed on algae and bacteria. Shredders have harder and more formed mouth parts. They will actually shred any sort of plant material that falls into the water. We do have predators that will predate on other larval insects and invertebrates, and then collectors that instead of building themselves rock houses, which we see to the right, they will actually build nets that lay on the bottom of rocks or different substrates. And these exist in running water, so anything floating by, like small invertebrates and debris, will be collected in the net, which they feed on. These species are really great indicators of water quality because they're very sensitive to oxygen levels, and so they're used in monitoring programs. So as you can see on the left, that's one of those collector net structures that I was mentioning. We have on the top here what it kind of looks like, an inside view into that house that they build. And on the bottom right is what the adult caddisfly looks like. Now I would like to play a video, so let's see if this works. I'm hoping that I'll be able to connect right away. I was hoping that I would be able to play them because they show the detail in such quality that it's hard to come across. And if I'm not able to play the video at the end of the session, I do suggest that anyone just go onto YouTube and type in keywords of the species names Caddisfly, Mayflies, and any species I've talked about today. And there are some really great educational resources available there.
And your slideshow shows the address on YouTube.
Yes, it does.
So people can go from there too.
So thank you for your patience, and we'll move on to the mayflies. They're within the order Ephemeroptera, and contrary to their name, mayflies actually are present in their adult stages all throughout May to September. But the reason that they have such a big impact on people and you're remembering them is they emerge in these massive rooms. So the short lifespan, living for about 1 to 2 days, and they do this when they emerge all at the same time. Their only thought is to focus on reproduction. Now, males actually have larger eyes than the females, and they have this adaptation in order to find a female throughout the huge swarm.
This is the larva of the caddisflyer.
Oh,
This installed the
it is flying now, so we'll try to go back to it later. I believe I've muted it for now, but you can still hear me, correct?
Hear you. Yes, we can hear you.
Okay, great. So where was I? The adults swarm in such large numbers that this is another one that you can look up on YouTube. There's videos of people actually shoveling piles off of their porch, and in some parts of the country, and especially down in the southern region of the United States, they put out weather reports on them because they'll actually reduce visibility on highways so much that people need to be informed about it. But in their larval stage, the gills are on the abdomen, as you can see here, and they are predators. Oh, sorry, they eat algae. I'm thinking another another one, but they're really interesting. If you ever go into a stream and just pick up a small rock, there's a possibility that you'd be able to see one crawling around on the bottom of the rock. They do kind of look like little aliens, the way that they have their legs bent like this, and the long tail on the end. But they're quite impressive and an interesting find. Now, one that's a favorite of mine and of many photographers out there are the order Odonata. And this order contains dragonflies and damselflies. If anyone's ever been on a canoe in a lake and been canoeing around lily pads or along the shoreline, you can immediately notice that the species in this order are great as adults. They are incredibly have the ability to zoom around very close and fast to the water and catch all of those insects and mosquitoes that we don't like so much. But they're also very fierce predators as larvae. The difference between a dragonfly and a damselfly, if you've ever caught one in the water, and this is also a difference you can see from the mayflies, their legs aren't as jointed, and there's a difference in slenderness and length. The dragonflies are often more thick. They have a wider abdomen, and as you can see, the structures, tail-like structures on the end of their abdomen are their gills. So I'm not sure if you have any kids in the audience today, but something that they always like to hear is that dragonflies actually breathe through their butt. Which is pretty funny even for an adult, I have to say. But this is a little different than the damselflies because their gill structures are much longer on the end of their abdomen, and their bodies are much more slender. Now, I'm not going to try and switch the video. Maybe we'll try to do them all at the end. But both species actually have a really interesting jaw structure, which they extend to catch prey. So if I turn sideways, they fold it up like this, and some of them have large pincers on the end, and they almost have a cup-like structure. So they'll wait silently for prey, and then this will extend outward, catch the prey, and pull it close so that they can chew on those soft invertebrates. And so I was talking about how the adults will actually eat mosquitoes in the air as they're flying around. Well, the larvae also help reduce mosquito populations by eating the mosquito larva. Another activity that I like to do, and feel free to join in. I know I can't see any of you, but you can see me. So we've been sitting for a while. Maybe we want to get up and move around. So something that I like to do is, how do you tell which one's which when you're just passing it by? And the difference is how to rest on maybe a twig or a leaf. Now, a damselfly will rest with its wings back folded behind its body. And this is because they're much smaller creatures and their muscles actually allow for that bend. Dragonflies, they have more muscle in those structures. They beat their wings a lot faster, and the result of that is that they're unable to fold them, and so they always rest with their wings outward. So that's something that you can pass on if you have any kidlets in your family that you want to teach them something about dragonflies and damselflies. Moving on into a different order of insects, we're going to talk about the order Coleoptera, or beetles. One that's pretty interesting is the predaceous diving beetle. As larvae, they are known as water tigers, which is another really cool thing, finding those similarities between their behavior that we might see somewhere else. They are ferocious predators, both as larval and adult stages. But as you can see here on the left, that jaw structure is pretty scary if I were a tiny invertebrate. And you can also see, it might be a little harder, but at the end of its abdomen, there are some soft hairs. Those are the gill structures that you breathe. Much like some of the other species we've talked about, these guys will crawl out of the water and pupate on land, but then enter the water again as adults. Many of the adults, the adult life stages, both male and female, will migrate between ponds and different bodies of water. While they're migrating, much like any other insect species, they're attracted to light, and the surface of your car can actually confuse them as the shimmering surface of water. So you might actually find them if you park near any sort of recreation center, and you might find one resting on your car. I've actually had them fly right into my lap while I was sitting with the window open in the driver's seat, which is pretty funny. Somewhat of tip for identification. If you've ever seen them paddle around, there's lots of different things that are moving through the water, but these guys will row or paddle with their back legs simultaneously. Some species will row with them alternatively. And I have another video. Hopefully we can try to look at that later, but it was trying to describe their breathing method. They actually will trap a bubble of water underneath their wings. So they come up to the surface, butt end towards the air and head down. They will bubble of water under their wings, dive, and then once they've used all the oxygen, they release that bubble and then have to surface again for more oxygen.
Abbie? Abbie?
Another beetle that we can talk about, this one is completely aquatic, is the riffle beetle, so the family Elmidae. I think these ones are worth noting and are interesting because the adults can't actually swim. Unlike the predaceous diving beetle, they don't have the modified arm structures for rowing, and they actually crawl around the substrate on the bottom of the bottom of the stream. Their breathing method is also different from the predaceous diving beetle. Now, the riffle beetles their whole bodies are covered in hydrophobic hairs that trap a thin layer of oxygen, and then they use that oxygen and it diffuses directly into their blood system. Now, the larvae have long, slender bodies, and like other species, they have their breathing structure at the end of their abdomen. Both larvae and adults feed on organic matter. Something that is really interesting, and it leads to their name, is that these riffle beetles are actually found in very fast-moving water, or the riffle zone. So I think it's pretty impressive that these tiny guys can hold on to the substrate, not knowing how to swim, and crawl around in some fast-moving water. So we're done a little bit earlier without the videos, but I wanted to go over kind of a summary of the different things that we've learned. We have talked about larvae that have gills on the sides of their abdomen versus ones that have them on the end of their abdomen. We've seen larvae, the caddisflies that can build their own houses and design, if you will, the structure that they're living in with their underwater tape. We've seen adults that can trap their oxygen under their wings versus ones that use hydrophobic hairs. With eating habits, there's a variety of carnivores, the filter feeders, and ones that feed on organic matter. There's definitely a lot of species that are completely aquatic. Some of the beetles we talked about fall in this category, versus ones that complete half of their life cycle on land. Thinking of the black flies and dragonflies. And especially there's a variety of beneficial insects that control some of our pests, and then, ones that they still play an important ecological role, but, we consider them a pest to us. I did want to go through some resources that are available to all of you. As a disclaimer, none of these are my personal property, but rather free resources that are available online. I was just recently made aware of a free app that's available on Apple Store called Aquabug. I haven't yet been able to dive into this one myself, but it looks very promising to document your finds and potentially, especially help ID some of the insects that you're seeing. I have been notified that it may not be available on Android phone, but I haven't been able to verify this claim yet. Something that's used not only by insect lovers, but also by some animal lovers, is iNaturalist. This is also a free app that's used to record observations and connect with a community that can help with ID. Lastly, I wanted to talk about Bug Finder. This is a free app that's available on both Apple and Android phones. It's not related to aquatic, but rather used for nursery and landscape pests. It has a whole host of information regarding the biology, but also tips and tools to ID what you're seeing. So thank you all for attending. I'm really sorry about any technological difficulties, but I would love to hear from you for questions. I think we'll do questions first, and then anyone who wants to stick around, maybe we'll try to pop back onto those videos.
Abby, so can people go out in the river and find all these things?
Yes. We did find all of these species last year when the event was held at the same time in May. But interestingly enough, we did find most, I would not say all, but most of these species even back in March.
Oh, okay. So after the river gets a little warmer, they appear?
Some of them do. Some of them may be hiding in the substrate, just a little harder to find depending on your methods. I do see a question from Sarah.
Okay.
Do mayflies smell like fish after they die? Personally, I think they do. I'm not sure on the scientific reason behind why they might smell like this. But I think it might have to do with maybe algae growth. If anyone does know the answer, the scientific reasons behind this answer, I'd be interested to hear it. But I do notice if you're ever on sort of like a pier structure on the shoreline, you get that kind of fishy smell. And I think it's due to the algae or anything that's growing on any of the pier structures, rocks, or anything that's in the area. And then the tide releases, and some of those things are exposed to the air, and then you get that smell. So this could be linked to that, and it could just be some form of a decay that's happening, and then the leaks of that smell.
I've been up in North Bay where the whole storefront's on the main street and the ground is covered with them. And it does smell. It does smell. I had never seen them before till I went up there.
Mayflies are definitely something that they make their presence known to everyone. Something that I can just mention, if you are wanting to go out and do your own sort of investigating in streams, I can just provide a quick list of tools that you might need. It's really easy if you bring any sort of white bucket with you. The white bottom or that color, once you put in water and kind of let all of the organic material settle out, the white background makes it a lot easier to identify things that are moving or crawling versus maybe a colored bucket or something that's a darker color. It's also good if you have any sort of nets that you can bring. Specifically, there is a net that you can buy called the D net, and this is manufactured specifically for doing collections in water. So I'd say those are probably the top two tools that you could use. But again, if you bring some other sort of bucket and place it in the water and maybe take a few steps up and move your foot back and forth and let things flow into that bucket, and then transfer that to the white bucket for viewing, that could be another sort of collection method.
Okay, any other questions from our participants? So I'd like to thank Abbie for her time and her patience. This is a learning experience for all of us. And we really appreciate that you took the time to make such beautiful slides for us and come up with the YouTube videos. To all of the participants, it was great to see your black squares with your names on, and great to have you join us. So check the 2Rivers Festival page for upcoming events and RSVP so that you can see them. Thanks very much. Thanks again, Abbie.
Thank you for hosting an introduction, and thank you to all the participants for viewing. We appreciate your attendance.
Okay, bye everybody.
Bye.